Hello, friends. You are welcome to another session on Code with Matt. If you are yet to subscribe to this channel, please kindly hit the subscribe button. And if you are yet to like any of our videos, you can encourage me by hitting the like button there so that YouTube can recommend these videos to others to watch. And I will be very, very, very glad you did. Thank you very much. We have started our series on learning C programming language. It has been a wonderful time here on the channel. The last time we looked at the anatomy of a C program and we talked a lot on so many things you are going to see in a C program. So we are going to continue from there. We are still actually learning the foundations of C programming language. Today, I want us to talk about the compilation process of a C program. So this is still foundation, the compilation process of a C program. Okay, so the last time we looked at this code, we wrote our first code and we printed hello world. And then to get this code working, we ran the compiler. We used GCC to compile it. So we use this command gcc hello.c, and then we use the flag O for the output and said hello. So then this gave us an executable which is all in binaries, and then we ran it and then we see hello world on the terminal. So this was actually our very first program. So, but a lot of things actually happened in this program that we need to understand. A lot of processes have actually, a lot of processes have actually been happened in order for us to have our executable and have it running well. So in this video, I'm going to talk about those processes and I want us to look at them properly, because actually you may need to split these processes in depending, you may need a particular output in the process. So without any further boring talks, let's dive into the topic. The compilation process of a C program. So in order for us to understand the compilation, we need to understand the concept of what happens when we write our source code in any programming language and how it gets to machine language, which is what the computer understands. Programming languages have two different approaches, and then there is really none that is better, but either of them could be the choice of the developers of the programming language that you are coding in. Right now we are coding in C, and C is a compiled language. Other programming languages like JavaScript and Python, they are mainly interpreted languages. So we need to understand what is this concept, compiled, interpreted. So anytime that you need to run a program and convert a program to machine code or into an executable before you can actually get the output of the program, that program is a compiled program. But whenever you can just run the program right from the source code right there, so as you're coding, you're just running it from the source code, it's an interpreted language. C that we are using, we are coding in presently is a compiled language, and we need to understand the processes, the steps in this compilation process. There are 4 steps in the compilation process. So these 4 steps are what it takes to go from your source code that you wrote to an executable file that you can run and you get an output for your code. So the four steps are the preprocessing, compiling, assembling, and linkage. So these four steps will be done by the preprocessor, the compiler, the assembler, and the linker, all of which are built into the compiler that we are using. In this case, we are using GCC. So all these are inside of GCC. The preprocessing. So in the preprocessing, the preprocessor works on the source code. Your source code has an extension of .c. So the preprocessor works on that source code first of all. It analyzes the source code and checks for every preprocessor derivative in that source code. And then it returns a preprocessed file, which if you want to output it would have a .i extension. So later on we may get to check all preprocessor derivatives, but we are used to the include that we've used all this while. We have used include. So we have used include in our program. So far we've used include. So include std.h is what we have used in this program. So what this is a preprocessor derivative. What include is a processor derivative, and that preprocessor derivative is what the preprocessor is going to deal with in this program right here, and it's going to expand it and give us an expanded code. So everything that you are including with include will be expanded. And if you have to use other derivatives, for example, you defined a macro, we will talk about those things later. You define a macro, it is going to, the macros will be used in your code, will be replaced in the code by the preprocessor. So the preprocessor gives us an expanded human readable file to output. So for us to get the output of the preprocessor, we need to use using our GCC, we need to use the flag -e. We need to use the flag -e. So coming back to our program, let's see this in action. So right now we have two files here, the executable and the hello.c. So if I were to have the preprocessor, I just want to output from the preprocessor, then I will use GCC -e. Then my program is hello. The source code is hello.c. Then I want to output it as hello.i. Now I have the hello.i file here. So you see the beauty of this is I can read it. But wow, you are seeing so many other things that I did not write. If you are coding along, you see so many things you did not write. Where are all these things coming from? Where are all these things coming from? Now, if you are going to check, just check, you will see that we haven't gotten to the beginning of the code we wrote ourselves. We've not gotten to the beginning. We've not gotten to the beginning. We've not gotten to the beginning. And then our code starts from here. Our code starts from here. So that means the include actually added all of these files, all of these lines of code. So all this line of code is contained in stdio.h. And another thing is that we did not see our comments anymore. We did not see our comments anymore. So the preprocessor removes the comments. It removes the comments because the comments are not for the machine. The comment is for anybody looking through the source code. So the preprocessor removes the comments. It adds everything that you are including. So everything in this header file is now going to be added into our source code. So our source code becomes expanded with hello and outputted as hello.i. So that is what happens in the preprocessor. Going back to our slides, the next stage is the compiling. So in this stage, the compiler converts the preprocessed or expanded code into assembly code. So remember when we spoke about different languages that are nearer to your machine code, to what your computer can understand. Your computer understands binary, right? And binary is machine code. Then there is a language nearer to binary, that is the assembly code. So it's so near to your machine code. However, it is still humanly readable, and a lot of people can actually write codes in assembly. It's a good skill to have. If you have such a skill, you'll be very good at debugging. You'll be very good at hacking softwares and code. So it's a good skill to have. However, in compiling, the output of compiling is assembly code, and the extension would be the .s extension. For us to see this output, we would have to use the flag -s. So let's head back to our program and let's see this output. So back in program, let's use our GCC. So GCC dash capital letter S, hello dot C. Let's output it as hello dot S. So now if you are using VS Code, you can see that VS Code has an icon. The icon beside this name is ASM. ASM stands for assembly. So you begin to see more. You see your code in assembly, written in assembly. So you don't need to understand this right now. At least if you can see something here, you're seeing dot string hello world. What we are printing out is hello world, right? You're seeing sections dot row data main. So these are different things in assembly. So if you understand assembly language, this will not be gibberish to you. So I encourage you actually to try to learn assembly language. Try to learn assembly language. So this is our main function. Okay. All right. So this is our main function right here. I myself am not so good at assembly language yet, but I actually have a little understanding if I see some things. But this tutorial, believe me, is not for assembly. Thank you very much. So let's continue with our presentation. So the assembling. So here, the assembler converts the code to machine code. So now you begin to have something that will make sense to the computer. The computer converts it to machine code, and that machine code is not readable to humans. The output, however, is not yet an executable, and it will have the .o extension. The .o stands for object file. So the output of assembling in this process is an object file with .o extension. So one of the uses of this output is when you are creating libraries, when you want to develop your own libraries, which is something advanced. When you want to develop your own libraries, have your own libraries that you can use for different programs, Your libraries are actually, they contain codes that you have written that you want to reuse in other programs. You could just have a library and a header file. So just the same way we are including stdio.h. So what we are trying to do is we are trying to tell our compiler that, look, I want you to get some functions from a particular library. So we'll have to add that library to our code. So we'll understand this later when we talk about the linking process. But let's try to output this in our code. So to get the result of assembly, we use the GCC dash the dash C flag. So the -C flag. So let's see that in our code. So go back here. We call GCC dash C. So in this case, it's a small letter C. Hello.c. So if I just press enter, it will actually name it for me. So it automatically named it hello.c. So this time around, you are seeing that it's not readable, right? If I click open anyway and use text editor, oh, I get a lot of gibberish. The only thing I've seen there is hello world and then Ubuntu. So ELF. So this is binary. They're all binary and it's not human readable. However, if I try to run it, you see permission denied. It's not an executable. So I cannot run it. So let's continue with our presentation. The next step in the process of compilation is the linkage. So here the object code produced is combined with other object files specified in the library to produce a working executable. The output may be a.out if you do not specify an output. On Unix PCs, you can have an output that is without extensions. Unix based computers are based operating systems are Linux, FreeBSD, um, Mac OS, and the likes. Those are Unix-based operating systems. But on Windows operating system, the extension would it will have a .exe extension. So basically, what happens is the source code is going to be after all the processes and then gets to the object file stage. The linker now combines it with different object files from the library. So all the functions that you call from different libraries, the linker gets their own binaries also and adds it to your code and then builds an executable from there. So it is now at this stage that your code can run. It is now at this stage that your code can run and can work on any similar computer. So the good thing about having a compiler is having a compiled language. The good thing about a compiled language is if I compile, for example, right now I'm running a Ubuntu Linux. If I compile a program on Ubuntu Linux, if I run that code on another Ubuntu Linux, it's going to work. If I run that code on similar on operating systems that are very much nearer to mine, a Linux-based operating system, maybe a Debian operating system, this code is going to run on that computer. So I can just move my executable up and down. And I don't need to start installing anything extra on that PC. But a language that is interpreted, I have my source code, which is going to be in a script form, and that my source code, for it to run on that computer, the person must have installed the interpreter. For example, Python would not work on a Python script will not work on any computer if that computer does not have a Python interpreter installed. So the same thing with JavaScript and code. So those ones, they need an extra layer of installation before the code can work. But for a compiled language, all you just need is you need to compile. Once you've compiled the code for operating systems that are alike, they are just it's going to work on similar operating systems. But I cannot take my code right now that I'm running on a Linux, that I've compiled on a Linux, and try to run the executable on Windows or Mac. It's not going to work. Okay, so I don't if I go back here, so this is our initial code that we have. This hello is the output of the linker. So there is no need for us to add any flag. All we just have to do is have our code. Sorry. So all we just have to do is just have an output, and then our code works. So this is our code right here. This is the executable, and then I can just run it. All right. So thank you guys. Thank you for staying to the end of this session. If you have any comments, feedbacks, or you have any concerns, please kindly use the comment section. I would reply as soon as possible. I will give my response. If you have anything you don't understand, kindly let me know in the comment section. Thank you very much. And if you are yet to like this video, please kindly click the like button so that we can be identified by the YouTube algorithm, and this video will be recommended to others to watch. And if you want your friends, you have a friend that wants to learn C programming language, kindly share the videos with them, subscribe, and you will get notified anytime I put up new videos. It's been a wonderful time with you. Thank you very much. Next time we are going to be talking about variables and data types. So we are going to dive deeper into coding in C, understand more concepts, the concept of variables and data types. So you don't want to miss it. Subscribe, get notified. See you next time. Bye, guys.